This is the homework helper for Chapter 12, Section 2 in the 8th grade workbook, Slope of a Line. So in questions 1 and 2, they're asking me to find the slope of the line. Now the approach you're going to use in 1 and 2 is going to be similar. So I'm going to go ahead and do question 2 with you, and you can use the same ideas to help you answer question number 1. So what you want to do here is you want to go ahead and identify 2 points that are clearly on grid markers based on the graph. And you can pick any ones that are on the line. So here, the ones that I see that are really easy to work with, right here at 0, 2, I see the line goes through a grid marker there. And also out here at 3, 0, I see the line goes through a grid marker there. So those are the 2 points I'm going to pick. You can pick any 2 points that are on there. The answer in the end will be the same. Remember, slope, which is what we're finding here, is comprised of 2 things. The rise, how much the line changes either moving up or down when we go from left to right, and then the run, which is how much the line is going to end up moving to the right. Remember, we're going to the right because we're always going to work left to right. So rise, we can go up or down, but because we're always going to work left to right for the run, I don't get a choice. I have to go left to right. So I'm going to start at this point and figure out how many units I'm going to have to move either up or down to get over here to this point. Well, in this case, I'm going down, so it's going to be a negative value. I'm going to make 1, 2 jumps down in my efforts to get over to this point. So the rise here is going to be -2. Then I'm going to calculate my run. My run, again, is how many units it's going to take me to move to the right to get to that point after we've already risen. Well, we're here now. To get over to this point where my other x is, it's 1, 2, 3 jumps to the right. And so my run being -3, this now represents my slope, because slope is simply rise over run. So my slope of this line is -2/3. Now you might say, well, what if I pick points further apart? Well, that's okay. You can pick different points. You can pick points further apart. The idea is, though, that when you take that fraction, it's either going to be equal to -2/3, or it's going to be something that reduces to -2/3. Divide it out if you're not really good with that division step, although you really should be, but divide it out if you're not seeing it, and make sure that your answer there, whatever you get if you pick different points, would divide out to equal the same thing as -2 divided by 3. That's another way you can check to see that your slopes are the same no matter which points you pick. All right, let's go ahead and take a look at 3 through 10. 3 through 10 is asking me to find the slope of the line that passes through each pair of points. So this is using the formula now to find slope. The formula for slope says what I do is I calculate the change in y and I divide that by the change in x. If you want something with a little more meat and potatoes to it, we can do that. We can say subtract y2 and y1 and divide that with x2 and x1. Now, remember, what those represent is that points are always written as x, y. So if we're looking at number 3, for instance, -2 is an x, and -8 is a y. 1 is an x, 4 is a y. Where do the 1s and 2s come from? Well, that simply represents the set of numbers that ordered pair is. This is my first set of numbers in the list, so they get the 1s. This is my second list of numbers in the set, so they get the 2s. And now that we've just labeled everything, now it's just a matter of dumping them into the formula to find the slope. Now, if you don't like the formula, the other option you have is to graph each set of points and then count it out. That's probably going to take you more time to sit there and make a nice graph and count it out, but you can do that. All right, but the formula says I'm going to take the y2 value and subtract the y1 value. So 4 minus -8 and subtract the x values, or divide by the difference of the x values, 1 and -2. Again, remember the formula says the second set numbers first, first set of numbers last. So 4 minus -8, that's going to change into a 12. 1 minus negative 2, that's going to change into a 3. Remember, minus a negative is the same as plus. 12 over 3 reduces to 4 over 1. In general, you want to write slope as a fraction because, remember, it represents our rise and our run. And sometimes we'll make the mistake, if we don't do that, of saying, oh, there's no run. When indeed, any number, when it represents the slope, unless it would be 0, is always going to have a rise and a run. All right, so let's go ahead and take a look at question 6. Again, let's start off and label our points. Again, x, y, always. 1s represent the first set of numbers. 2s represent the second set of numbers. Formula says I'm going to subtract the y values, second set minus first set first. So I'm going to do negative 4 minus negative 6. And I'm going to divide that by what happens when I subtract the x values, 2 minus 3. Now, minus a negative here again is going to change into plus. So negative 4 minus negative 6 is really negative 4 plus 6, which is 2. 2 minus 3, that's negative 1. So the slope of the line that goes through 3, negative 6, and 2, negative 4 is 2 over negative 1, or negative 2, or negative 2 over 1. They would all be equivalent. And again, you could sketch those points, put down 3, negative 6 on a coordinate grid, 2, negative 4 on a coordinate grid, count it out. You will see that the slope of the line that connects those points is 2 over negative 1, or negative 2 over 1, or simply negative 2. All right, let's go ahead and take a look at the story problem here, number 11. Number 11 says that the table shows the distance Mrs. Long traveled as she went to the beach. Use the data to make a graph, find the slope of the line, and explain what it shows. Okay, so what we want to do here, as far as making a graph, is they've set this up comparing the time and the miles. So we're going to compare these like time represents x, y, because they put it on the x-axis, and like the miles represents y, reasoning because they put it on the y-axis. So at time 8 minutes, the distance covered is 6 miles. Well, as you can see, this graph is going by 2, so to get over 8, I'm going to make 4 jumps to the right, and then to get up to 6, I'm going to make 3 jumps up. And there's 8, 6. For 12, 9, well, again, if it goes by 2s, and here's 10, the next one over is 12, and then I'm going to go up to 9. Now remember, this fourth jump was to be 8. This jump here is marked 10, so it's halfway between 8 and 10. 16, 12 here. So I'm going to go over to 16, 12, 14, 16, and then up to 12. That's going to be 1 jump up from 10 because remember this is going by 2s. And then 20, 15 for the last one. So all the way over to the time marker for 20. And as we go from 10, here's 12, here's 14. The next one up would be 16. We've got 15, so that's between 14 and 16, which is right there. Okay, so now we're going to go ahead and connect those points to show that it is a line. Obviously, it would make sense here that the graph would start at 0, 0, because remember, what are we talking about? The time we've traveled and the distance we've traveled. Well, if I haven't spent any time traveling, I can't have gotten anywhere. So for the graph to start at 0, 0 simply makes sense. So I'm going to make sure my graph touches 0, 0, and I'm going to connect my points that I've made, an arrowhead on the right end, and there we've gone ahead and made the graph, which is one of the things they've asked us to do. Now what they're going to ask us to do here is to find the slope and explain what the slope means. Well, remember, these are my x's as we graphed them. These are my y's. So the formula for slope, like we saw in the beginning there, tells us I can count the rise and the run to go from point to point. So let's say I decided I wanted to pick this point and this point. Let's go ahead and find the rise and the run there. Well, to go from this point to this point, I went 1, 2, 3 jumps up. But remember, every jump really represents 2, so 3 jumps actually represents a rise of 6. All right, then when I've gotten up to here, I'm going to then have to go 1, 2, 3, 4 jumps over. But again, every jump represents 2, so the run here is going to actually be 8. Well, if slope is rise over run, my slope here is 6 over 8, or if we want to reduce it, 3 over 4. Okay, so now we have our slope. Now we have to explain what the slope means. Well, remember, one of the definitions of slope is it's the change in the y over the change in the x. Well, what does the y's represent? The y represents the miles, the x represents the time. So the slope here represents the change in miles over the change in time, which is a very good, clear definition based on what we know slope means. So we're going to start off here and we're going to say that it represents the change in miles compared to the change in time. If we want to give it a little bit more meaning, since we have the numbers 3 and 4 there, that means for every 3 miles of distance being covered, there's 4 minutes of time elapsing. Because again, the first number is miles, 3 is what we figured out from the slope. The second number is time, 4, again what we figured out from finding the slope. Every 3 miles, there's 4 minutes of time elapsing.